Hello again, everybody, and it is Thursday, and so let's get right into it. We're going to start with talking about yesterday's brain structure, because since we're in our Earth Science unit, well, part of the Earth is our atmosphere, which is just that layer of air that is held in place by the Earth's gravity. That's why larger planets have an atmosphere, things like the Moon, or if you've ever looked at Mercury, they're smaller, they don't have as much gravity, and so they don't have enough gravity to actually hold those air molecules around the surface of the planet. So luckily we do have that atmosphere, and we did a little experiment with it yesterday. So I took a bottle kind of similar to this, and it's just one that had been finished being used, and it did have a little dent in it, kind of like this. And then I drove, so I live in Loveland, and it's interesting that a couple people even looked up elevations. And so, here where I live, it's a little over 5,000 feet. Well, then I happened to drive up to Pinewood Reservoir, which is over 6,000 feet. And so just that change in elevation, the lower you are in the atmosphere. So like if you're at sea level, there's a lot more air above you, and those molecules are a lot more dense. Does air have weight? Yes, it does. You don't think of it like, ooh, look, a molecule, a molecule. And the higher you get, the fewer molecules there are. So the lower your elevation, they're more densely packed, so there's just simply more molecules in the air around you. And so it is slightly heavier. So at the lower elevations, that air is squeezing in a little bit. And by just changing it a little over 1,000 feet, then that bottle then no longer looked like that, and it just looked like a normal bottle. So what we're going to show you right here, I've got an electronic scale right here. And so going along with the idea of, does air have weight? We're going to prove that it does. Alright, so on this scale, I am going to put just a little piece of Scotch tape, because when I blow up the balloon, it'll want to kind of blow away and won't want to sit there on the scale. So I'm going to put the tape on there, because tape has weight too, of course. I'm going to hit 0, so this is going to just zero it out. Alright, so right there, you can see, so it says 0. So I've zeroed it out. That's its starting point. So first, let's just weigh the balloon. So I'm going to just lightly set the balloon on there. And we have, what do we have? 41.4. Now this is in grains. There are 2,000 grains in a pound. So grains you're using to measure things that are really, really light. Which for some of the things I do, I need that. So, right now it weighs 41.4 grains. Alright, so if air doesn't weigh anything, if we air this up and put it on there, it should weigh what? Yeah, good job. Yeah, 41.4. So, let's blow it up. Notice I even got school colors. Yay. Hey. I was never very good at tying knots on these. Okay. Let's put Mr. Balloon on there. And you can see it's bouncing around a little bit just because the lightest of air currents will affect that. But yeah, let's see right now, 45, 46. Here, I'll try not to blow on the balloon. Anyways, it's been about 45 point something, and now it's at 46. So that's actually a pretty good increase. And so we went from 41.4 to 45 or 46 grains I'm going to try to take that out without that tape popping the balloon. Okay, yay. Give the cat something to play with. So, air does have mass, it does have weight, and so once again, so if this is sea level, and say here's the upper part of our atmosphere, well, right there, you've got a lot more air above you. Think about if you've ever dove to just the bottom of a 8 or 10-foot pool. On the bottom, you feel the pressure on your ears because it's the weight of that water at 10 feet deep is a lot more water weight pushing down on you than if you're up here. Same with the air. So if here's sea level, here's the top of the atmosphere, well, if here's 5,000 feet and then here's 6,000, well, at 6,000 there was a little less air pushing down than at 5,000. Doesn't seem like it'd make that much difference, but you can see in this case it did. So good job on that. Today's brain structure kind of deals with something similar, and some people had some good guesses as far as something else that could have affected that bottle, which I don't want to talk about right now, or else I'll give away the brain structure answer for today. But go to today's brain structure, and I've got another little just situation for you, and then we'll talk about that one tomorrow. Okay? Then let's talk about a few things with today's lesson. So, moving on from the brain structure. So, please check today's brain structure, send me that. It kind of ties in with yesterday's as far, I'm do the brain structure and send me your best guess. Appreciate all the involvement and interesting guesses people have been sending on those. So you're watching the video lesson for today right now, obviously, duh. And then when you finish this, do watch. I've got a video, not one that I made, so I don't want to totally bore you to death. And so there's just a few-minute video about plate tectonics. Figured somebody better than I am at making these videos had done that one, so I thought it was pretty good. So watch that, and then I'll explain the next project. So I'm going to go to screen recording here, and we'll go over a few things, and I have changed a few things on the website. Okay, so I am screen recording, I think. Let me pull up EstusParkSteam.com. And I have moved a few things around, so let me point out those. I need to change that homepage picture, don't I? We've been looking at Lauren for about a week now. Probably getting sick of her. Alright, so here on the 7th grade science page. So the upcoming stuff that used to be over here, I've moved it off to the side just because we're going to have so many more videos and things like that than we used to have. I just think this will make it easier. So, let's see. And then, of course, so here's where today's lesson that you're watching right now is. It's not there right now because I'm making that video right now. So when you finish that, then watch this Plate Tectonics for Kids video. It's pretty good and it's real short. Just gives you a good overview of plate tectonics. Then, let's see. Oh, a couple other things. So I still have some things posted from Unit 6 because I know there's a few people that were still finishing up or that were gone or having some tech difficulties early on. So there's what we did the week before spring break, the first week that we had online school. Here's the things posted from Unit 6 over here as well. So for most of us, though, we care about this stuff. Also, the videos that I'm making, so we've got Wednesday's lesson there, and then there's Tuesday's there. Whoops, shoot. So those are going to be there for you in case you miss a day or what have you. All right, let's go. Where'd my little finger go? All right, so let's go open the Inside Earth project now, because up here's the history of the Earth assignment that most people have already finished. Remember, this is due today. And so now let's talk about this next one. You were getting, I had originally 4 things that you were going to work on. Well, so people, I've been so impressed with people. I'm going to help you out. So let's cut it down to 2. You're going to do 2 of these 4 options. So let's see. So option A is just on the Earth's structure, how the Earth formed, layers of the Earth, and then how the continents have moved over time. The red book that we handed out, and that book is titled Inside Earth, just like this unit is titled Inside Earth. That will help you on a lot of this. Or once again, the internet is a great source. Some of these, the old saying, a picture is worth 1,000 words. So, like the movement of the continents over time, that would be best shown through pictures and diagrams. Layers of the Earth, the crust, mantle, core. Diagrams would be great on that. You want a little bit of information. And then formation of the Earth. Remember, the Earth is, scientists think, billions of years old. So we're looking for just general overviews. Don't go into crazy detail on any of these. And as always, however you choose to do it, Keynote, iMovie, if you want to do it by hand and take pictures, whatever works for you. So option B, remember you're doing 2 of these 4. Option B and C are my favorites because option B is on earthquakes, C is on volcanoes. So if you choose to do option B, so earthquakes occur on fault lines, and you have a lot of places in the world that have a lot more earthquakes than other areas. So look up some, let's say 3 historic earthquakes, and just tell us a little bit about where they occur, when, what made them significant. Maybe it's because they had were really high on the magnitude scale as far as how much shaking was going on, or maybe it's because they had a lot more damage or deaths, because obviously a earthquake in China is probably going to have a lot more damage or potential death, just because there's a lot more people there. So it'd be worse than having an earthquake in Antarctica. So pick 3, research 3, just write a little bit about those. And then earthquake prevention, and the book has some good stuff on this. A lot of places like our West Coast, highly populated, and they have a lot of earthquakes. So with building design, they do some things that keeps those things from falling down in earthquakes. Japan probably is the leader worldwide in this. They're on a couple of fault lines that come together, and if you remember there's the nuclear reactor that was where they had an earthquake. I think that was about 2012, 13. I can't even remember, but anyways, so that's a little bit about earthquakes. Option C, rocks and volcanoes. Just hit the rock cycle real quick again, refresh us on that. And that's another case where a diagram might be easier than anything. So we'll just refresh us on that. Talk about types of volcanoes. And that's in the book. The book does a nice job on that. And then once again, if you do this one, let's say just pick out 3 historic volcanoes, famous ones in history, and there's lots of those to choose from. And remember, not every volcano is something destructive. Like the one in Hawaii just a couple of years ago. That was kind of cool. We cruised around Hawaii and saw that one. Hawaii is nothing but volcanoes. That's where it came from. That's why you have those islands out in the middle of the ocean. And so, anyways, there's lots of things to choose from there. And then the last one, and this one, I know the book talks about convection. I'd have to go look. I can't remember on the other 2. You might have to look in the index, or you might have to look them up. But energy and heat transfer, and this deals with heat within the earth or in the atmosphere. There's these 3 main methods in which heat moves around. And by heat, that also refers to cold, because cold is really just a lack of heat. Heat is infrared energy. So you could look these up, and these also would be really well done with diagrams. Or what I've seen done best on these is people making their own diagrams, like on notability, and maybe picking out some examples. of each of these and just using that. So anyways, all right. So you are doing how many of these? Yes, very good. 2. So choose 2 of these 4 options. So for today, please just get that the history of the earth thing to me if you haven't. And remember, email it to me and just put history of the earth for the subject. Yeah, Schoology's been a mess for people, it sounds like. So just, email this stuff to me. Get going on this. We'll have this due Wednesday, and that'll be that. So, all right, I'll check in with you again tomorrow. So thanks for the good work, everybody.